Okay, in this video we are going to calculate the sample standard deviation when the mean does not come out evenly. So we always start by finding n and x bar. So n in this case is 6. So now when I add these together I get 10, 18, 28 divided by 6. Now that's not going to come out evenly. Let's see what I get. 28 divided by 6. And I get a repeating decimal, so I'm going to have to round this mean to 4.7. Okay, so that's not the exact mean, so it's not the exact balance point of the data set. But that's what we're going to use here to calculate the sample standard deviation. And we'll still be able to calculate it. It'll be pretty much the right value. It might be off a little bit due to rounding error. So it's just going to be maybe a little more work. It'll be a little more tedious here. So, okay. So S here is going to be the sum of x minus the mean, 4.7 squared, divided by 6 minus 1. Take the square root. Okay, and so then I'll draw my light circle, divide by 5, take the square root. So I need to get this number, so I'm going to use my table here. So list out my values: 1, 9, 3, 5, 7, and 3. So now I gotta subtract here. So I'll take 1 minus 4.7, and you see I get a decimal here. So this is negative 3.7. So 9 minus 4.7, this is positive 4.3. So 3 minus 4.7 is negative 1.7. And 5 minus 4.7 is 0.3. 7 minus 4.7 is positive 2.3. And then 3 minus 4.7 is negative 1.7. Okay, so just a little messier here because the numbers aren't even. Okay. Also, when I go to add these up, they will not necessarily cancel each other out exactly, but they should be close. They should be close. So let's see what happens when I add these up. So 3.7 plus 4.3 plus negative 1.7 plus 0.3 plus 2.3 plus negative 1.7. And look, I get negative 0.2. Okay, so not quite 0. But close. Does that make sense? Because this isn't the exact balance point of the data, so these won't exactly cancel each other out since I had to round that. So, but it's going to be something, you know, negative point something. Okay, and so now I gotta square all these, and again this is going to be just a little more tedious because I'm going to use my calculator and I'm going to get some messier numbers. So I'm going to just ignore the negative sign. So 3.7 squared, 13.69. I can ignore it because negative 3.7 squared and positive 3.7 squared are both 13.69. Okay, so 4.3 squared is 18.49. 1.7 squared is 2.89. 0.3 squared is 0.09. 2.3 squared, 5.29. And then 1.7 squared is 2.89. Okay, so these are my deviations squared. So now I need to add those together. So 13.69 plus 18.49 plus 2.89 plus 0.09 plus 5.29 plus 2.89. So add those up, looks like I get 43.34. Okay, so this is the number then that goes up here, 43.34. And so now, excuse me, now I'm going to divide that by 5, and then I'm going to take the square root, and I get, this is going to round to 2.9, and that is the standard deviation. Okay, so when this does not come out evenly, you round to the tenths place, okay, and you do pretty much, it's the exact same procedure. Nothing changes except that your numbers are a little messier, and you probably are going to use a calculator, and it's a little more tedious to type everything in. And the other thing is, when you add these together, it won't equal exactly 0, it'll just be close to 0, okay? But otherwise, you calculate the sample standard deviation in the same way. So in the final video here, I'm going to give you a chance to do one where it doesn't come out evenly.